dear learners, myself Dr. Sandeep Kumar Bansal, Professor at Ramesh Institute of Vocational and Technical Education, Greater Noida. And I am discussing unit 2nd of the subject Pharmaceutical Organic Chemistry, that is BP 401T. In our previous discussions, we have discussed about the geometrical isomerism, how geometrical isomerism arises, what are the various methods that is utilized to determine the configuration of geometrical isomerism. And in our just previous lecture, we had discussed what is conformational isomerism. And in that lecture, we had also seen that how it arises, what are the various energy barriers to this conformational isomerism, and in terms of they were torsional strain and the steric strain. And now, in this present lecture, I am going to discuss about the conformational isomerism with reference to ethane, n-butane and cyclohexane. So, we are going to discuss 3 compounds with reference to conformational isomerism, that is ethane, n-butane and cyclohexane. So, first of all, let me write down the formula for ethane. It is, we know, C2H6, butane C4H10 and cyclohexane C6H12. So, we are going to discuss all these 3 molecules conformational isomerism with reference to these 3 molecules. Now, let us start with the ethane. The structure that we are representing for ethane is like this. This is a very common structure generally we used to draw the ethane, that is but this structure is not very much informative. What does it mean? It means it does not give much information. So, to render, to get more and more information, what we can do? So, we can represent this structure of ethane like this. So, here we are calling it Wedge and dash projection structure. Here we are taking the help of 3 bonds, dash bond, wedge bond and the straight lines. So, what dash bonds are representing? Dash bonds are representing the bonds that are going away from u in space. So, this is basically representing 3 dimensional structure. On the other hand, that we have drawn 2 dimensional structure, that is not giving very much information. So, it was this. So, 3 dimensional structure we are drawing with the help of wedge and dash bond. So, wedge dash bond is representing the bond that is going away from u in the space. Wedge bond is the bond that is coming out at u in the space, and straight line the bond that is present in the plane of the phase. So, we are taking the help of 3 bonds, again dash, wedge and straight bond, straight line. So, all the 3 lines or 3 representations are representing in a different way. Wedge and dash bond are representing the molecule in out of the plane, towards us, away from us, and straight line representing the bond within the plane of the phase. Now, what is happening? If we allow one of the carbon atom to rotate about the carbon carbon bond. Now, how it rotates? See, here you can see one, we are keeping one carbon stationary and another carbon moving. See, so if we are allowing to rotation of one bond like this, what is happening? It is creating infinite number of arrangements. It is creating infinite number of arrangement, and these infinite number of arrangements we are calling them conformations. So, these arrangements we are calling, what we are calling them? We are calling them as the conformation. But remember this, the bond angle and the bond length remain the same. So, the quality of these conformations is that the bond angle and bond length remains the same. So, how many conformations are there? Conformations are, there is no limit. So, conformations are infinite in number. So, by the rotation of carbon single bond, we are getting infinite number of conformations, and the beauty of this conformations that bond angle and bond length remains the same. And out of numerous conformations, we are looking for two extreme. We are looking for two extreme conformations. Now, what are these two extreme conformations? So, to understand these two extreme conformations, we have to look molecule like this. We have to look molecule along the carbon-carbon bond in the Newman projection formula, and that three-dimensional structures of alkanes can be represented by Newman and Sahorst that we have discussed in our previous lecture. So, my dear students, so look this Newman projection at carbon-carbon bond, and here you will found that these CH bond are at minimum distance from each other. So, this type of conformation, when the substituted hydrogens or some other groups depending on compound to compound are at minimum distance possible. So, these conformations are called eclipsed conformations. These conformations are called eclipsed conformation. So, dear students, remember that when we are talking that the conformations that is resulting due to the minimum distance, the possible minimum distance between the groups. So, that conformation we are calling it as a eclipsed conformation. Now, if we look upon again, look this structure from the carbon-carbon axis, and if the distance is maximum possible distance, then this is a very beautiful structure, and we are calling it as the staggered conformation. So, while having numerous conformations that is infinite in number, so we are considering two extreme conditions. The extreme condition, one is called eclipsed, another is called staggered. So, eclipsed conformation means the substituents are at minimum distance, and the staggered, the substituents are at the maximum distance, and the intermediate conformations that are present between staggered and eclipsed, they are called skew conformation. Now, in continuation, let us see. So, let us see energy changes during rotation around carbon-carbon single bond. In staggered conformation, the electron cloud of carbon-hydrogen bond is as far as possible. As we have looked in the structure. So, for easiness, let me draw this structure again. So, if we are having this structure, so if we talk about the electron clouds of these two particular compounds, these two particular hydrogens H A and H B. So, electron cloud is as far apart as possible. So, it is at maximum distance, and when staggered changes into eclipsed conformation, these electron cloud come to each other. These come to each other like. Now, what is happening basically? When the electron cloud comes to each other, there will be maximum repulsive interaction between these two electron clouds, and this repulsive interaction is termed as torsional strain, and this repulsive interaction increases the energy and henceforth resulting in the lowest stability. So, least energy and staggered conformation we are calling with least energy maximum stability, and eclipsed conformation we are calling with maximum energy and minimum or lowest stability. Now, we can see both the conformations with the help of a diagram. You see less stable due to torsional strain, this is eclipsed conformation. Here are the staggered conformation, most stable, and the energy barrier between these two conformations is 12.5 kilojoule. So, maximum potential energy, minimum stability, minimum potential energy, maximum stability. So, these are the extreme conformations of the ethane molecule. And the repulsive interaction between electron cloud which affect the stability of conformation is called torsional strain, and staggered conformation is almost stable due to least torsional strain. Out of these two strains, we are talking about eclipsed and staggered. So, staggered one is the most stable due to the least torsional strain. Now, there is one more terminology that we have to encounter during this discussion of conformation, that is the dihedral angle as a result of torsional, or we call it as a torsional angle. So, it is represented by the symbol theta, and in case of eclipsed it is generally 0, and for staggered it is 60. Now, what does it mean? What is this dihedral angle of torsional strain? If we are looking again this molecule along the carbon carbon axis, and let us focus on the atoms A and D. So, they are very near to each other. So, in this case dihedral angle is 0. Now, if we are looking this again, see both the A and D substituents are far apart from each other and at a dihedral angle of 180. And these particular types of arrangements are called syn periplanar or syn coplanar, and this is called anti periplanar or anti coplanar. So, dihedral angle between the peripheral substituents that are meshed possible distance or minimum possible distance. So, they are eclipsed or conformations or staggered conformation. So, here I have represented all the possible conformations. You see that eclipsed, staggered and intermediate skew conformations. So, both of them are represented with the help of Newman structure, Newman representation and the Sahor's representation. So, as we know that we can represent Newman and Sahor's representation to represent these types of conformation. Now, next term is conformational analysis. So, study of the energetics of different conformation of a molecule is known as the conformational analysis. How, what for it is done? It helps to predict which conformation of molecule are favored or unfavored. Means favored or unfavored means which is stable, which is most stable and which is least stable. So, as we know staggered conformation has the minimum energy and eclipsed conformation has the maximum potential energy, and this difference, energy difference is 1 to 20 kilojoule, and this energy barrier is very small, and this energy barrier to the rotation of around carbon carbon bond. So, in our previous lecture I have told you that the conformational analysis we are assuming that this carbon carbon rotation is almost free, but it is not exactly, actually it is not free, it is having certain barriers, and the barriers are this energy barrier around of 1 to 20 kilojoule per mole. And if we talk about at room temperature, ordinary temperature, ethane molecule possesses thermal or kinetic energy that is of order that can cross this barrier very easily. So, intermolecular collisions can overcome this barrier easily, and different conformations of ethane molecule that can readily change into one another, and it can be easily concluded that rotation in carbon carbon single bond is almost free. So, remember this line and try to understand this, ethane is almost free. So, it can be easily understand that why this energy barrier is very small and intermolecular collisions can overcome this barrier. So, therefore, it is not possible to separate and isolate different conformations of ethane. So, that is why we are using what term we are using? We are using the term that it is almost energy free barrier. This energy barrier is very low, it is order of 1 to 20 kilojoule, and effective intermolecular collisions are sufficient, possess sufficient kinetic energy. So, that it can overcome easily. Now, next molecule is n-butane. So, n-butane has 4 carbons. I have told you that this is C4H10. Ordinarily, we represent butane like this. ethane we have this represented like this. So, there is the addition of 2 carbons from ethane to butane, and this symmetry I have represented in this molecule here. In ethane, 2 terminal hydrogens are being replaced with the methyl, and resulting molecule is the butane. So, 1 hydrogen of from each atom of ethane is replaced by the methyl group, and that is the structure of butane. Now, how we are representing this molecule? We are representing, considering there are bonds. How many bonds are there? So, there are two central bonds and terminal bond. So, there is 1 central bond and 2 terminal bonds. Let us have a look over the rotation of this n-butane. So, this is the beauty how we can represent the butane in different conformations. So, my dear students, as we have seen with the case of ethane, the conformations, there were only 2 conformations, namely that one was staggered, another was the eclipsed, but there will be more staggered conformation as compared to the ethane. Let us see how these are possible. See, extreme are the anti and the fully eclipsed. So, students, try to understand this. So, anti form that these 2 methyl groups are far apart at 180 degree separation from each other. Now, let us, I am rotating this rear carbon and methyl is rotated like this. Now, what is happening? This hydrogen and methyl are coming in the proximity with each other, and what is the angle between them? This form is called eclipsed. Now, if I am further rotating this methyl, so now it acquires this conformation, and the bond angle, the dihedral angle between these 2 methyl groups is 60 degree, and we are calling it a Gauche form. Now, if I further rotate, now these 2 methyl groups come close to each other, and that angle is 0, and we are considering it fully eclipsed. On further rotation, these angles acquire, the dihedral angle again is 60, we are calling it Gauche. Again, the angle is 0 between methyl and hydrogen, and further rotation give the our antiform back. So, this is the dihedral angle that is having various values with reference to the, if we talk about the ethane, the values were, the conformations were hardly 2, one was staggered, another was the ethane, one staggered, another was the eclipsed. But in this case, we are having number of intermediate conformations, skew conformations, that are eclipsed, fully eclipsed and Gauche. So, let us see the energy values for these. So, here with the help of this diagram, we can see very clearly that it is anti conformation, eclipsed, Gauche and eclipsed. The angle is again 180, here 60, 60, here it is 120, again here is 0. So, the dihedral angle is deciding here which conformation will be most stable, which conformation will be less stable. Let us see the stability. Now, this is the energy diagram or conformation analysis. Here see, there are different energy barriers: eclipsed, fully eclipsed, eclipsed, Gauche and anti. So, the energy barrier between anti and Gauche is 3.8 kilojoule, and similarly, the energy barrier between anti and fully eclipsed is 22.2 kilojoule, and the energy barrier is 14.6 kilojoule again in eclipsed and the anti. So, these are the various energy barriers, and depending on this energy barrier we can say stability order, we can define, and stability order of this is anti, Gauche, eclipsed and the fully eclipsed. And here if we can observe one more phenomena, that there are two possibilities are there, conformational enantiomers and conformational diastereomers. So, these two conformations we are getting in meanwhile, that is if we are comparing this structure, what we are showing, the third and fifth. So, third and fifth are the conformational enantiomers, and first, third and fifth are conformational diastereomers, first and third. Out of any, if we are considering this, these are the conformational diastereomers. So, there are again more and more possibilities in case of the butane, as let us call back ethane. In case of ethane, there were only two possibilities were there, that staggered and eclipsed, but in case of butane there are number of conformations are possible, and these conformations are resulting in the enantiomers and the diastereomers. And the stability order is that anti is the most stable, followed by Gauche, followed by eclipsed, followed by the fully eclipsed. Now, the conformational isomers are readily interconvertible, hence they cannot be separated. Energy barrier is hardly 22 kilojoule per mole, and it is as low as to overcome with the help of the intercollisions. So, collisions are sufficient, kinetic energy sufficient, so they can overcome. So, at its rotation is almost again as it was almost free in case of ethane. So, again it is almost free in case of the n-butane. So, it consists equilibrium mixture of all the possible conformation, highest proportion is of first and fourth, because being the most stable. Now, next molecule to be discussed here is the cyclohexane. This is very important. So, if we talk about the regular hexane, so formula is C6H12. So, if we talk about this is angle 120, regular hexagon, but if we talk about the carbon carbon bond angle, that is dihedral, that is 109. Now, what does it mean? So, there must be some conformation, some wrapped conformation to decrease this bond angle from 120 to 109, and this wrapped conformation reduce overall stale energy, and cyclohexane undergo the puckered conformations, and these conformations are called chair and boat conformation. So, that is why the cyclohexane ring is very important, because it virtually strain free. It is one of the reason why compound containing 6 membered ring are very common, they are very common. If cyclohexane were planar, that had to be 120 and it become 109, that is why there are two conformations possible, that boat, twist boat, chair and half chair. So, 4 conformations are mainly, there are mainly 2 conformations, chair and boat, but although we can classify, categorize these them as chair, twist boat, boat and half chair. So, this is energy level also there. So, which is more stable, which is less stable energetically. Chair conformation, in chair conformation 2 types of, we are representing 2 positions, axial and equatorial. Axial position represent perpendicular position of the ring, equatorial position represent the bond that are horizontal in. So, these bonds are axial up, axial down, equatorial up, equatorial down. So, this type of structure is possible with reference to the cyclohexane. Now, question is that how to draw this chair conformation. So, there are steps. So, we have to draw 2 lines, place one atom here and join it, place another atom and join it. So, in this way beautifully we can draw the chair conformation, and there are 2 representations of chair conformation, that is one is one is Sohor's, another is the Newman. Similarly, boat conformation, again it is identified with the 2 plague hole hydrogens. So, these are the Newman structures, Newman representation of the boat conformation, and this is the conformational analysis which is most stable. So, from this diagram it is very clear that the chair conformation is the most stable and the boat conformation is intermediate with intermediate stability. So, these which is more stable chair, twist, boat. So, we can represent with the help of diagram. So, this is about the conformational analysis of the cyclohexane. So, thank you students. I hope you must have understand the conformational isomerism with reference to this ethane, butane and cyclohexane. So, in next lecture we will discuss stereo isomerism in biphenyl compound, that is atropisomerism, and the stereospecific and stereo selective reactions. So, thank you very much.